Okay, and part D finally says, look, find or sketch the graph of this function. Now what we've done is we've found all the major points that we need on this graph, and you'll see why in a moment. In fact, the graph, it wants a graph of the velocity function, or v of t. Okay, it says what's sketch the graph. Okay, that's the question. So let's try and draw the graph. I'll try my best to get some nice axes. Okay, so on this should work. There we go. Okay, so we have velocity. Whoops, that didn't quite work. There we go. It's a little bit better. V. Again, I'm still struggling with this. There we go. Okay, v of t and time there. Okay, so as time increases, what happens to the velocity? So the first thing we need to know is when time is equal to 0, where is velocity on this line? What is velocity? What is the magnitude of velocity? Okay, if we go back to part B, you'll remember when t is equal to 0, velocity is 60 centimeters per second. So we get back down to our graph. Let's say we call, I'll pick a point, let's say that one. Yeah, okay, that one. Stop here, make it nicer. Okay, I'll pick that point as 60, so say 20, 40, let's mark it. Not very accurate, but yeah, 60. So we start at that point, and as t increases, when we looked at this, we said what happens as t approaches infinity? We said the velocity approaches 100. So the velocity never quite gets to 100, but it approaches 100. Okay, so if I just draw a line in a slightly different, let's pick that color. Let's say I mark that point as 100. Okay, and put a line in for 100. Okay, that's looking pretty cool. Back to that. Let's be brave, we'll try another color there. Okay, so what happens to velocity? We know as t increases, velocity increases. Okay, so velocity does something like that. Okay, but it never quite gets to, wasn't very good. It increases, but it never quite gets to 100. Okay, gets close as t keeps increasing. I'm not going to be able to do this very well, but as t keeps increasing, this gets close. Oops, gets closer and closer to 100. Okay, and we can try making this as close to 100 as we possibly can. But that's what the velocity of this particle p will do. At t equals 0, it starts at 60, starts increasing its velocity because it is accelerating. We found the acceleration function, goes all the way there, tries to get close to 100 but never quite reaches it. Okay, so that is the graph. Okay, I guess if I was really brave, I'd put a line through that. I didn't think that would work. Let's leave that out. Okay, but you can draw a nice hard line on a piece of paper. Okay, but that's the graph of the velocity function. Okay, it's usually nice to also, when you're drawing a graph, make sure the axes are labeled. Okay, you've got your axes, your velocity, and your time. You might have x and y, or displacement and time, whatever it is. It's always good to do that, and it's also sometimes, or not sometimes, but always good to sort of write down what the graph is. So in this case, you could even say it's the velocity function. Okay, that. Okay, just something like that to keep everyone happy. Okay, that's the velocity function. And then finally, part E, it says what's the velocity of p? Find when the velocity of p is 80 meters per second. Okay, so what it's saying is at what time t is the velocity 80 meters per second. Okay, from our graph here, I'd say 60, 80 would be around there. Okay, now this graph isn't to scale, so that doesn't really give us a good indication of where it'll be. Okay, but that's, I'll call it time 80. Okay, so at time when t is equal to when the velocity is equal to 80 meters per second, what is the time? Okay, what time does 80 meters my apologies, it's centimeters per second, not meters per second. And what time does the particle reach 80 meters per second? So looking at the graph, we know what it means. So how do we do that? What it's asking us to do is look at the velocity function, which was way back here, okay, and find out what t will be. Okay, so just going back down, and finally I'll write this out again. Okay, and it's asking us velocity of p equals 80 centimeters per second. Okay, find t in seconds at that point. Okay, so we need to find t. So the velocity function we know is equal to 100 minus 40 minus t on 5. Okay, and we're trying to find t, but we know that the velocity of p is 80 centimeters per second. Okay, which is equal to 100 minus 40 e t on 5. Okay, bringing the 100 out to this side, so we have now 80 minus 100 equals minus 40 minus t on 5. Just make a bit more space for ourselves there. Okay, so now minus 20 e to the minus t on 5. Okay, divide both sides by 40, or minus 40 ends up giving us minus 20, but minus 40 is t on 5. Okay, we end up with a half equal to e to the minus t on 5. Okay, I've got you down up to that point. From here you should be able to find t. I won't go through finally and work out what t is. I'll leave that final bit for you to solve. I'm sure all of you are able to solve that. If you're not, just go back and have a quick look at the earlier chapters, which shows you how that last bit is done. So from there you'll be able to find what t will be. Okay, so that is problem 13 from exercise 19D. Done. I'll see you next time.